Hello again. So now that we've done we've created the API, we need to actually create a Xamarin.Forms app that receives the notifications and can register a device to receive notifications. So we'll go ahead and go to multi-platform and create a blank Forms app. I'll call this push demo app, and here we are. Okay. First thing we need to do is set the bundle identifier to actually make sure that it matches the bundle identifier that we have. In iOS push demo app, I'm not sure if it's case sensitive, so to be on the safe side, we'll just do that. And in the properties, Android manifest, okay, that's absolutely fine. Now if you've got the docs open in front of you, the first thing we're told to do is to update all the Nuget packages, and I think that is important, so we will do that. Accept the licenses. This might take a bit of time. Okay, that's been done. Now we need to manage Nuget packages and add the Newtonsoft.json. That should be the first one here. You can add that package to all three. Oops, I did not add to all three. Do that again. Add it to the iOS app as well. Okay, that has been added successfully. Now the first thing we do is forget about the Android and iOS native projects. We just look at the shared .NET Standard library, and we need to create, first of all, a models folder. And this models folder is going to contain a lot of the common business logic and a lot of the common stuff we can share between the two projects, as is with the whole of the .NET Standard library. So the first class we need to add into here is device installation, and that will be the same, at least with these components, for both Android and iOS. So you can just copy and paste this in. We'll have you'll need a using directive, Newtonsoft.json, and system.collection.generic. And so this JSON property installation ID platform push channel tags will just tell it will, so that the application knows this is what we're referring to with this property installation ID platform push channel and tags. Okay, and the next model, the next class we need to add to models is push demo action. Now the push demo action is actually not going to be a class. It's going to be an enumerable, an enum, and it will hold our two actions. In this case, we'll just have action A, action B. These actions could be whatever you like, depending on your app, whether it's to I don't know, send in a message to the user saying there's a new version of the app, go and update it, or maybe to say there's a new message that's been received, or maybe the database has been updated. I hope you get the idea. Next thing we do is add, we're done with models for now, we add another folder called services. And in the services folder, first thing we add is a service container class. Service container class will be a static class, and I'll just copy and paste the implementation, try and go through it. So it's going to have a dictionary here, and the dictionary will represent the services themselves, and the key will be the type, and the value will be the object, whatever it is, and it will be of type lazy. So what lazy does is it doesn't actually create the object until it has to create it. Here we have a register method. This register method will it will use the type T, and it will pass a function template with a template T, and it will actually add that to the dictionary using the type of T and a new lazy object, which is a parameter of the function passed in. The next thing resolves it, and resolve does the following, and so it takes the type and it says if services.tryGetValue type, so if it is already in the services dictionary, then it just returns service.value, and if it's not, then it says key not found exception, service not found for type. So resolve basically just gets our service from the dictionary. The next thing is an interface. An interface here, an interface, and we'll call this the Idevice Service interface. This interface will have the following. Have a token property. It will have a notification supported, and only with a get, not a set. It will have a method that returns a string called getDeviceID, which will probably return a device ID, and it will also have a method called getDeviceInstallation, which returns a device installation, and we pass to that some tags. So I just want to demonstrate what this does, params. This will just mean we can say getDeviceInstallation, and we can we can pass tag 1, tag 2, tag 3, as opposed to putting these in an array. Okay. The next thing we need to do is create another interface in the services folder. iNotification registration service interface. And what this will do is we'll have 3 methods that return a task, and one will be to deregister a device, one will be to register a device with the specified tags, and one would be to refresh the registration, so to ensure the registration has the correct token that's been generated. The next thing we need to do is create yet another interface called the iNotification Action Service. And what this does is we'll have a single trigger action method, string action, and we don't know much about this. So when we do come and implement the interface, we'll know what the docs mean. In fact, when we're talking about triggering an action, it will probably be something to do with receiving an action and doing something about it, as you can tell. Now the next thing we need to do is yet another interface, new class interface, iPushDemo notification action service. And this will just be, it will have an event handler, and the event handler put push demo action in there. Do need a using directive to the models, and action triggered. This event handler, we will see, it says in the notes in the docs, this type is specific to the push demo application and uses the push demo action enumeration to identify the action that is being triggered in a strongly typed manner. Okay. If we add an empty class now to the services folder, this time we're going to implement an interface, and this class will be called the notification registration service class. and this class will implement the iNotification registration service. Hence we need to implement the interface, and there are 3 methods that we need to implement. First of all, here we need to specify a few constants to make our code more readable, really. And the first one is API/notifications/installations, and this will be the so we'll have our main URL from our API, which will be something like namespace.Azure.Service.Bus or something like that, .net, and then /API notifications installations. The next thing is the constant cached device token key, and this will be just cached device token, and this will, the only reason we're going to use this is to, I must say string here, the only reason we're going to use this is to use Xamarin.Essentials, the secure storage class, and it will just we'll just be saving and getting this from secure storage using this key or identifier, if you like. And the next one is cached tags key. That'll just be cached tags. Now, as far as I know, you can call this whatever you like. These 2 values can be whatever you like, as long as they don't change from between run and run. Now, we'll also need a string base app API URI, and that will be what I was talking about, the servicebus.azure or something like that. You know, the one we got from our API. HTTP client. These are just fields that we'll be assigning to. So here in the constructor, we'll specify that we need the following URIs. We'll need a base app URI, and we'll need our string API key. And so when we have got those, we just assign them. So first of all, we'll create a client, new HTTP client. We'll say client.default_request_headers.add accept and application JSON, and we'll add to the client default request headers.add API key and API key. So this will just add these headers to the request that we make whenever we make it. Base app URI, we'll just assign that to base app. We'll assign base app URI to that field. Now we're done with that, we can add an Idevice installation service named Device Installation Service, and we use a lambda expression here, and we say Device Installation Service I'm going to say that is that, and this operator, we'll see what that means in a second. I'll just copy the rest of the code here and explain what this does. So this says if we need the device installation service here, this is a property in fact, then we look at device installation service, so this field here. If this is not null, this is what this property does, this operator does. If it's not null, we'll just use device installation service. Otherwise, if it is null, then we'll use whatever is returned by service container.resolve Idevice installation service and assign that to that field. That's basically pretty much it. Now we have our task, register device async. Now I should mention that these all will be async. First thing we do is try and get the cache token, await secure storage, We do need Xamarin Essentials for that. .getAsync cached device token key. .configureAwait false. Now this is just to do some to do with tasks and threading, and we need to could pretty much shake this off really, just so that when we do throw an exception here, it won't actually be an exception that will crash the program, but it will be an exception that will have a value that we can use to provide meaningful messages either for the user or for our crash analytics, or our just general analytics. So we say if the cache token is null, then we've got a problem. So we just return. Now, so we take the device ID and we check if the device installation service exists. If it does, we call the getDeviceID method. And if you look here, we have actually specified that that method needs to be implemented in the interface. We haven't implemented it yet. And so we check if the device ID is null or white space, device ID, and if it is, then we have got a problem. So we throw an exception, unable to resolve an ID for the device. Remember, this exception will not cause the application to crash. However, it will, this method will not continue from there. So we'll try and await send async, which is a method we haven't actually created yet. We'll be doing that in a second. It will take the following parameters, so http method.delete, so this will be a delete request, and we'll pass the endpoint here. So it will be the request URL, / the device ID, and we'll configure await false, and I'll actually control dot and create that, and we can worry about that later. Secure storage dot remove. So now that we've got the cache token, we've got the cache device token key, we're deregistering the device, so we can just remove those at this moment in time. Cache device token key, and we'll also remove secure storage dot remove cached tags key. Now we can actually implement this method here. And I'll just cut it and put it down here so that it's easier to follow up. And I'll change these for it to make more sense. So this will be the request type. This will be the request URI. And we'll also add another optional parameter, and that will be a string JSON request. And that will be null by default. And this JSON request will simply, in the future, or maybe in this app, I'm not too sure. But if we do want to add a body to our request, we can do that by using this parameter. And what this will do is it will form the request. So be a new HTTP request message of type request type, of URI, new URI. Take the base app URI, request URI, because our request URI here doesn't actually have the base app URI inside it. And we can go ahead and do that. Now, let's see if the JSON request is null. If it isn't null, then we want to add it to the content of the request. new string content JSON request. Encoding will specify that we want encoding use system.text UTF-8, and we'll also mention media type is application JSON. Now, once we've got that, we get the response. To get the response, we do await client.send async request, the request we've just formed, .configure await false. And I'm getting an error. Okay, this has to be async. Response.ensure success status code. Okay, now the next thing we need to do is implement these as well. So to register a device, I'll just do it as the docs have done it. I'll put that on top of here just so that it's clear. Register device async. So we'll get the device installation. Device installation service dot get device ID, and let's see if let's see what we can do. So we'll await send async device installation. This will be a different method. It's not the same one. It'll be an overload. We need models http method dot put request URL device installation. Okay, to register a device async, we'll need the device installation, and it'll be the device installation service dot get device installation using the tags, and we'll await send async. And this, notice this will be a different overload, because this will need device installation like that, and you will need a using directive http method dot put request URL and device installation. And this device installation will eventually be our JSON request. I should say device installation like that. And then once we've done that, we can save that to secure storage. So I'll set async cached device token key device installation, and that is a small d dot push channel, and we'll do the same for the tags as well. And that'll be tags. And in fact, we will have a problem here. I'll just cut that, and we need to serialize this first using JSON converts. JSON convert.serialize.object, and put that in there. Now that should be fine. I can generate this method, and I'll put it down here for clarity. And this will take our request type and our request URL, and this we've passed a device installation. However, this actually can be anything. So the docs have called it object. And what this will do is we'll have a string with serialized content, and we'll have it as null for now. And then we'll await task.run, and we'll use a lambda expression here to specify what we need done. We need to use JSON convert.serialize.object .configure await false. Okay, and we do need to make this async. What this does is basically does this, but uses a task to await it. The next thing we need to do is await send async, which is this method here, and we can now call it using the request type, the request URI, or the request URL rather. I've called it the URL, you can call it the URI if you like. Serialized content. Serialized content by this point is going to be a string because we've serialized it. And that's pretty much it. Now we need to refresh a registration as well. First thing we do is get the cache token, secure storage dot get async cache device token key dot configure await false. Serialized tags, also get those from secure storage get async cache device tags key cache tags key rather configure await false. Then we'll get we'll analyze what we've got and see whether we should continue or not. So is null or white space? If our cached token is null or white space, then we have a problem. If serialized tags is null or white space, then we have a problem. And is null or white space, if our token is null or white space, then we also have a problem. That's device installation token. And if our cache token is the device installation service token, then actually we don't need to refresh anything. It's all up to date. So if any of those are true, we just return. Otherwise, we'll deserialize the tags, Json convert deserialize.Object into an array of strings, serialized tags. So we'll have that as an array of strings. And once we've got that, we can just register the device basically again. And when we register a device, this method is called. And that's pretty much it. It's a big class, and we've got all the functionality in here. The next thing we need to do is add a class to services, and this will be called the push demo notification action service. And this will implement the iPushDemo notification action service. We'll implement the interface, and it's got an event handler, and first of all we'll have a read-only dictionary here. I'll just copy that in. This will just map action A, which will be passed as part of the notification request, as part of the notification in fact that arrives. It will map that to the enumerable. And there we are. Now this action triggered, we'll equate that to, we'll assign it to empty delegates. And what we'll do here is we'll take away the constructor. We don't need the constructor. However, we will need a new method which will be public trigger action string action. And what this method will do is, first of all, work out if the action received is just invalid, and if it is valid, we will do that by try get value action out the push demo action. And so if we haven't got that value, then we just return straight away. If we have got that value, we can just continue. We'll create a list of type exception. Exceptions equals new list exception. And for each handler in action triggered .get invocation list. So this will be in action triggered here, for each handler, which will be of type delegate, system.delegate, we'll try to invoke this push demo action, and if this doesn't succeed, we'll add this to exceptions, and once we have done that, if there are any exceptions, so if exceptions.any, you'll need link for this, then we'll throw new aggregate exceptions, and this, okay, now that that is done, don't worry too much about what's in here. This is basically, this code will not change. The only bit you will have to change is this. The next bit is to add an empty class to the project itself, and it would probably be nicer to put this in a folder, but we'll do as the docs say for now. Config, and this will just be a static class, and it will have two static public static strings. First one is the API key, and the second one is the back service endpoint. So public static string backend service endpoints equals backend service endpoints. And obviously these are placeholders. The docs tell us to override these values using a local partial class, just so that where these secrets are not found in source control. And I'm not too worried about that, so I will just specify them here. My API key is my API key, and my backend service endpoint, well, we'll need to go to Azure. Notice here that I'm just about to put in the wrong endpoint. In fact, I put in the default listen access signature, and don't do that. Make sure you put in the namespace, and it'll be in the server in the format of something.servicebus.azure.net or something like that, and this will be corrected later on in the video. The next class we need to make will also be in the root here of the push demo app project, and this will be called Bootstrap, and this will be a static class with a single static method. And this will basically just register the services in the service container, and we'll only be calling this when the app first runs, so that these services in the service container, i.e. in this dictionary services, are available for us. Now, our logic is pretty much done. What we need to do now is implement the user interface. So for that, I'll open mainpage.xaml, and I'll take all this out. We don't need that. And in fact, I'll just copy it straight from the docs. What this will do is we'll set us two buttons, one that says register, one that says deregister, and I'll just create these event handlers and create this event handler as well, just so that it's generated straight away in the code behind. Now if we go to mainpage.xaml.cs, we do have those event handlers there. First thing we need to do in the code behind is put in a read-only field here that is initialized in the constructor. So in the constructor here, I have the notification registration service equals service container dot resolve iNotification registration service. And this will just return that service from the service container that we registered in the Bootstrap class. And here, in the event handler, I'm just going to copy exactly what's in here, except I won't use a lambda expression for the whole thing. I'll just put it in there. So this will call show alerts. It's better if we put it on one line. This will make more sense, and we don't need that. Okay, I'll just do exactly the same thing for now in deregister, except we're going to deregister and we're going to deregister. Okay, and we need to actually, we haven't got this method yet, so I'm going to make that method. And what this is going to do is invoke on the main thread the following. Let me just tidy this up. So it's a single line of code here. It's going to display alert push demo message. Okay, continue with the task. If the task is faulted, throws the new task.exception. This will not crash the program again. We'll need Xamarin.essentials for that. We're all good to go. Now finally, when an action is when a notification is received, well, there are two different things that could happen. Either our application could be open and running in the foreground, or our application could be running in the background. Now here we'll be talking about the foreground if a notification is received while the app is opened, or when the notification is clicked and the app is launched because of the notification. Now that functionality will be implemented in App.Xamarin.cs. So if we go to App.Xamarin.cs, notification action triggered. Okay. So we need to implement the event handler for iPushDemo notification action service. And I'll just put that in here. And we do need a using directive here and there. And that is absolutely fine. Now in the constructor, we'll need to use service container. We'll need our service container dot resolve iPushDemo notification action service dot action triggered, and we'll plus equals app action triggered, and this will actually be just this. What I'm going to do is just rename this and forget about that. Okay, so that is called when so we just subscribe to that, basically subscribe to that event, the action triggered event. And so now our shared .NET standard library is complete. Now we may have an error, a typo here and there. I'm not going to focus on that. We can figure that out when the time comes. The first thing we need to do is configure the native Android project for push notifications. So we'll open it. First thing we do is go to the Android manifest, and we need to first of all make sure the package name matches. We have made sure, and we need to set the minimum Android version to Android 8. We're told that only devices running API level 26 and above are supported for the purposes of this tutorial. I haven't tried it with earlier versions, so I don't see a reason to try it with earlier versions. I'm going to just target Android 11. And we need to make sure internet and read phone states, those permissions are available. What I would also do is access network state. Okay, that is already available. Now that this is done, we can save it. What I would do that's not mentioned in the docs is go to General here, and either Android 10 or 11, probably 10 is more suitable. Now, we need to add a few packages. The first one is our manage Nuget packages, Xamarin.Google.Play Services.Base, and we'll add that package, accept the license. Once that's added, we need to add another package, Xamarin.Firebase.Messaging. Add that package. Need to accept the license terms as well. We'll need to add the Google Services JSON file that we got from Firebase when we registered the project. I'm going to add an existing file, and I'm going to find that here, wherever you saved it. And once I have got it in here, you need to right click, or control click in fact, build action, and select Google Services JSON. Now this is only available once we've installed the Nuget package Google Play Services.Base. Once that is done, we can go ahead and handle push notifications for Android. Now, we'll need to create a new folder here called Services. And this Services folder will have several classes, the first one being Device Installation Service. We'll implement that, and it's got a few things in here. First of all, we'll look at the constructor. According to the docs, we don't need the constructor, and we don't need anything apart from this. Well, token, our get and set aren't implemented, but we don't need to implement them. That's fine, we can just leave it as that. Notifications supported will we'll have to call Google API availability. You will need using Directives dot instance dot is Google Play Services available, application.context, Android.app context. If that is equal to connection results.success. Now, so this will be a Boolean because it will just evaluate this expression. So it'll say this will return something, and if it is success, i.e. yes, it is supported, then it is supported. What this will do, get device ID, is secure, which is Android provider.settings, so this is platform specific, .get string, application.context, .context resolver, secure .android ID. This is platform specific and will just get us that, and we will need to return that, of course. Finally, we've got our device get device installation. Get device installation will before I implement that, I'm just going to copy and paste a method from the docs here. There we are. This will just return a meaningful error depending on what the error is really. So we'll go and say if notification supported. If they're not supported, we'll throw a new exception new exception, throw a new exception of, we'll get the error using that method. And if we don't have our token, then we'll throw a new exception unable to resolve token for FCM, so Firebase Cloud Messaging. Otherwise, we'll create a new installation, a new device installation, and it doesn't have a constructor. Installation ID equals get device ID. Our platform is FCM, and our push channel equals the token. And that's pretty much it. Finally, we'll add to the installation the tags. So the tags.addRange tags. And these are the tags that we've received here. And it's saying we're not returning anything. That is because we need to return the installation once we've got it. That's basically it. Device installation service is now implemented, on Android at least. Now we'll add another empty class to the services, and this will be the push notification Firebase Messaging Service class. And this will inherit from Firebase Messaging Service. And this needs to have the service attribute, and we'll also need an intent filter, which will be a new array com.google, and make sure your spelling is on point, messaging events. And what this will do is we'll have these properties in their backing fields, which I'll just copy and paste. We will need a single using directive. Okay, what this will do, and I'll put this on the same line so it makes more sense. We looked at this this operator earlier. What this does is looks at the notification action service, and if it exists, then it returns it. However, if it's null, then we will assign service container.resolve, whatever that returns, to the notification action service and just use that. We've done that 3 times for the separate things here. And now we need to override 2 methods. The first one is on new token. So if we have a new token, DeviceInstallationService.Token equals the token. So it says P0 here, and I'll just rename that to token. Notification registration service dot refresh registration async, since we have a new token here, dot continue with task if task dot is faulted, throw task dot exception. I think we need a colon there and there. Okay, it's absolutely fine. The second method we need to override is on message received. Method, and this is the message that's been received. We'll say if the message.data.tryGetValue action out of our message action. So this will try and get the value. If it does, it'll essentially output a variable that we can use in this if statement. So notification action service dot trigger action and this is seems we're missing something. The notification action service. Okay, what I have realized is we haven't implemented in the iPushDemo Notification Action Service interface, we actually need to implement another interface, which is the iNotification Action Service interface. And that way, trigger action has no problem. Now we can continue, and this is done as well. So we can close these and go to main activity. First thing we need to do is set the launch mode equals launch mode dot single top, and we need to add private properties and corresponding backing fields to store a reference to the iPush Notification Action Service and Idevice Installation Service. We need some using directives. Again, I went through this, you should know by now what this does. And we need to do a few things here. First of all, we need to implement Android.gms.tasks.IOnSuccess listener. And we can implement this interface. As you can see, this adds this method here. And this should just return the DeviceInstallationService.Token result.class. Sorry, it shouldn't return that. It should just do that. Result.class.get method get token .invoke result.toString. Now this would be done slightly differently in Java. In Java, you just use the get token method, but since this is Xamarin and we're using C#, obviously they've done it slightly differently. So now we need to add a new method, and I'll just copy and paste that in from the docs yet again. And this is the process notification actions, and we need a using directive there, and this just looks at the intent, and if it has an extra, so this is like essentially passing a parameter to an intent, if you like, and this is Android specific, of course. If we have got action, then we get the action and we trigger action using the notification action service. If we have got an exception, we just write that down so that we can understand what's going on. We'll also override the onNewIntent method. And the reason we'd override this is because we set the launch mode to launch mode.singleTop. So as it says in the docs, an intent will be sent to the existing activity instance via the onNewIntent method rather than the onCreate method. And so you must handle incoming intent in both onCreate and onNewIntent methods. So essentially we won't be calling only onCreate, we'll also be calling onNewIntent. And so what we'll do here is just process the notification actions in the intent, if there are any, of course. Next thing we need to do is look at base.onCreates, and just underneath it we call bootstrap.begin, and we pass the action here, which is a new device installation service. And I'll just do that. And add the using directive. Okay, that does that. Afterwards, we'll also need to check if installations are supported. Sorry, notifications are supported. If they are, then we call FirebaseInstance.ID.getInstance FirebaseApp.Instance.getInstanceID .add OnSuccess listener this. Now you will notice you get a warning saying this is deprecated. For now, I'm going to use it as is and see what works and see what doesn't. And later on, at the end of this video, I'll come back and use the newer version of this. After we load the application here, we process the notification actions, passing the intent here. And that is pretty much it for the Android. So we can run this, and I just need to, due to having the Apple Silicon chip, it doesn't work. We've got a preview Android emulator, so it doesn't work exactly as planned. Need to launch the Android emulator. Was getting a few errors, and the errors were caused by this selection. Actually, I left it as 10. It works on 11. We'll have to try it and see what happens. So if I run this, I build and run, and I'll have the Android emulator up, and I'll have Azure here as well. I'll get ready to test send to an Android phone. Just wait for this to build. Okay, so it appears we do get an error, another error, and I think we can fix this by installing the following Nuget package. And this will be Google Dagger. If I run that again, okay, so as you can see, that worked. Let's see what happens. So if we come and register, one or more errors occurred. Invalid URI. I think the reason for that is because we go to config. I put the wrong endpoint here. So make sure you do add the correct backend service endpoints. And make sure there's HTTPS, not HTTP. So if I debug that now, and we'll see what happens. Okay, so first of all, I'll register the device, and we get a successful message, device registered. So now, if I close the app, just let it run in the background, and if I go to Azure, and if I go to test send Android and send the notification, I get a notification here. Notification hub, test notification. That corresponds to this title. And the body is that. And the same thing would go for if I made a post request from Postman. I'll just do that here. So if I made, and I'll make sure this is HTTPS actually, and our body is message from Postman, action A. Send that. We get push demo, message from Postman. And notice that our title and body, we don't write title and body here, we write text rather, and action. And our program translates this into a title, which is push demo by default according to the API backend. If you look at the push templates class in the API, this is our default class. This is our default title, and we could easily add a title here to the body so that we can use this. But there we are. That works. Now for iOS. Close this, and indeed close this. Open iOS, and we'll go to the docs, and the first thing we need to do, I'll close all of these. First thing we need to do is go to info.plist and notice we didn't actually create a provisioning profile when we came to do this. So what I will do is open this up here, and I will create a new provisioning profile, the iOS app development. We'll select the app ID, which is push demo app, continue, I'll just include all of them, and we'll include my phone, and we'll call this push demo app. I like to put PP0, the first provisioning profile, just so that if we have one for development, one for distribution, one for, whatever it is, generate, download, and we'll just download it, install it. Now it's installed. Okay, so if I go to bundle signing options, in developer, automatic will be selected and it will be fine, or we can explicitly set it, which is usually more robust. And once we've got that done, we can set our deployment target to 13.0, and I don't see the reason for having to support anything earlier than that, really. Then we go to entitlements.plist, entitlements tab, enable push notifications. Notice this is now added here. This is set to development at the moment. When we do want to roll out for production, when we do want to send this to the App Store, for example, we will need to change this value, and I will do a video on preparing our application for production when it comes to push notifications. The next thing we need to do is, like Android, create a new folder here, and the new folder is services, and in here we'll add a new class, and this is, as with Android, device installation service, and I'll just copy the implementation directly from the docs and include UI, use UI kit models. Okay, that's all fine, and we'll also need that. Okay, so this has got a token, notifications supported. We'll use UI_device.current_device.check system version, which will just make sure that our system is running iOS 13.0 or later. And then we've got device ID. We get that by calling UI_device.current_device.identify_for_vendor.toString. And then we get the device installation using those tags by, first of all, checking notifications are supported, then making sure the token actually is there. And then we get the installation ID, the platform, the push channel, and add the tags and return the installation. And then we've got a similar method here to show us, to get us a meaningful error message rather. The next step is to create a new folder called extensions, and we're going to have a single extension here, and new class. I'm going to call this NS Data Extensions. I'm just going to paste this in. All this does is converts our data to hexadecimal string, apparently. Don't worry about what's in here. Next thing we need to do is configure App Delegates Dot Cs. First thing we do is copy these in directly, and we do need I think a single using directive. There we are, and this does exactly the same thing as with Android. Let's put these on the same line so that it makes more sense. Okay, and then we've got we need to make we need to create a new method called register for remote notifications. And what this will do is it will invoke on the main thread the following. And so we'll get the push settings. In fact, what's in the docs is, as far as I know, is slightly outdated. And due to it being outdated, we need to use an updated version, which is not push settings, slightly simpler. So what we need to do is we need to say UN user notification center dot current dot request authorization, and the types are alerts that we need. We need UN user notification is bad, and we need sound. And we'll also pass a completion handler, granted error, and if it's granted, then we'll invoke on the main thread, so main thread dot begin invoke on main thread. And in fact, actually, we don't need to have this here. What we need to invoke on the main thread is UI application dot register for dot shared application dot register for remote notifications, and that should be absolutely fine. We need to create a task, or in fact a method that returns task, so an async method, complete registration async, and this will take NSData device token as a parameter. What this will do is it'll set DeviceInstallationService.Token equals device token dot to hex string, and that is the method we have in the extensions folder. And this will return return notification registration service dot refresh registration async. Also, we'll need to add the process notification actions method, and this will take user info. User info will actually be the payload itself. And say if it's null, return. Otherwise, the action value will be try and get the object for key, the action, and if we have an action, which we will have in our payload, then we'll trigger the action value dot description. Then we'll override the registered for remote notifications method. And here, what we will do is complete registration async, passing the device token, and continue with task if task dot is faulted, throw task dot exception. Okay. We also need to override the received remote notification here. and we'll need to simply just call process notification actions, passing user info as the parameter, and we have that here in the override. Finally, we'll need to override fail to register for remote notifications, and all we'll do here is debug.writeLine, just so that we can see what's going on, see why we have failed to register for remote notifications. You might want to, as it says in the docs, you might want to, whether you want to implement some sort of event report or error whether you want to make an error report or an event report or whatever you want to do here. Finally, in the finished launching method, in here, we'll want to call bootstrap.begin, passing our implementation for iOS of the device installation service, and you do need a using directive. Okay. Finally, we will need to call this right after, which will just request authorization for notifications. Last thing we do is it says still in finished launching, call process notification actions, and we'll do this right after load application. And we're using user info as options.object for key, launch options remote notification key as an NS dictionary process notification. So that's basically just how we get it and send it. So if I were to run this now on my device, switch to iOS, select my device, run it. We've got this loading, and straight away it asks, we'd like to send you notifications. So we'll allow that. And we've got two buttons, register and deregister, so we'll try registering and see what happens. Woohoo, device registered. Device has been registered. So I'll exit the app, and on here in notification, so once it's running in the background, what I want to do now is go to Postman, and I'll just run this request here, see what happens. You get a message from Postman, from Post.mo app. Everything works perfectly. And now we've successfully configured a Xamarin.Forms application to receive notifications from Azure Notification Hub. And this is done through the Web API backend that we created, which I didn't mention actually, is in main activity. I did change from this deprecated version to this version. You don't need any additional packages. It's all there. Instead of using Firebase instance id.getInstance and all that, FirebaseMessaging.Instance.GetToken add OnSuccess listener this. Also OnSuccess here in the method, you change result.class.getMethod.getToken that to FirebaseMessaging.Instance.GetToken to string, and that will work perfectly fine. And in the next video, what I'm going to be looking at is configuring this application for production. So that means for submitting to the App Store and to test flight, so that your notifications actually work. Because actually, if you don't configure them correctly, you'll be very disappointed because you've been waiting for some time, and you'll notice that unfortunately even though they've approved your app, your notifications don't work. Thank you.